morning all. My name is Deepak Kumar. I am the assistant professor in RKGIT. Today we will study the fundamentals of control system. These are the contents of my presentation. Today's topic. First is introduction of control system. Second is classification of control system. Third is continuous time and discrete time control systems. SISO and MIO control systems. Open loop and closed loop control system. Transfer function, block diagram representation, and standard test signals. First of all, we would know what is the control system. A control system is a system which provides the desired response by controlling the output. It means control system is a system by which we control the output of any plant to get the desired response. The examples of the control systems are traffic light control system, washing machine, immersion rod, etc. Now the classification of control system. The first classification of control system is the continuous time and discrete time control system. As it is shown in the figure, the first control system is the continuous system. In continuous time control system, input and output both are the continuous time signals. Means input and output both are in nature continuous time. And in discrete time control systems, both input and output are discrete in nature. This is the first classification of the control system. Second classification of control system is the SISO and MIO control system. As it is seen in the figure, in SISO control system only one input is there and one output is there. But in multiple input, multiple output control system, there are multiple inputs and multiple outputs in the control system. The examples of SISO control system may be like immersion rod, because there is only one input and one output. But in MIMO there are multiple inputs and multiple outputs. We can understand this with the example of like aircraft control system, because in aircraft control system there are many inputs and many outputs. The third classification of control systems is open loop and closed loop control systems. As it is explained in this PPT, control system can be classified as open loop control system and closed loop control system based on the feedback path. In open loop control system, output is not fed back to the input, so the control action is independent of the desired output. In the open loop control system, there is no feedback. And in the closed loop control system, output is fed back to the input, so the control action is dependent on the desired output. हम लोग ओपन लूप कंट्रोल सिस्टम में किसी भी तरह का कोई फीडबैक नहीं होता है, और क्लोज लूप सिस्टम में आउटपुट को हम लोग फीडबैक करते हैं इनपुट की तरफ. As the block diagram of the open loop control system is shown in the figure, input is given to the controller and controller is generating the actuating signal which is going to the plant, and we are getting the output. The example of open loop control system is the immersion rod. In immersion rod, thermostat is the controller and plant is the heating coil. And as the supply is given to the immersion rod, we just get the temperature of the water. It is the block diagram of closed loop control system. Here it is clearly seen that the output is fed back through the feedback element into the controller. Here the work of error detector is to generate the error signal which compares the input to the feedback signal and it gives to the controller. According to this error signal, controller generates the actuating signal. This actuating signal goes to the plant and we get the desired output. The example of the closed loop control system are automatic electric iron, water level controller. As we can understand closed loop control system with the help of automatic electric iron, as the temperature of the sole of the iron goes up through the sensor, the feedback goes to the input and the power supply is off, and vice versa. Same in the water level controller. As the water level goes up and down compared to the reference, the feedback comes to the input and the level, we get the desired level. This is the difference between open loop control system and closed loop control system. As in this slide, the feedback element is absent in open loop control system and the feedback element is always present in closed loop system. जैसे मैंने बताया अभी कि open loop control system में कोई भी feedback नहीं होता है और closed loop system में एक feedback होता है. Second difference is an error detector is not present in open loop control system, but in closed loop control system error detector is always present. Same, जो open loop system जो होता है it is stable one, closed loop system is not stable. Open loop control system is easy to construct, closed control system complicated to construct. Open loop control system it is economical, closed loop system it is costly. Open loop control system having small bandwidth, closed loop control system having large bandwidth. Open loop control system is inaccurate, closed loop system is accurate. The maintenance is less in open loop control system and the maintenance is higher in closed loop control system. Open loop systems are unreliable, closed loop systems are reliable. The examples of open loop closed system are hand dryer, tea maker, and examples of closed loop control system are servo voltage stabilizer and perspiration. This is the basic difference between open loop control system and the closed loop control system. Now we will study what is the transfer function. Actually, transfer function is the ratio of Laplace transform output to the Laplace transform of input. This is shown in this slide. TS is the ratio of Laplace transform of output to the Laplace transform of input. It is a very important parameter. As it is shown in the figure, the transfer function of the open loop system and transfer function of closed loop system. Here we can see that this is the block diagram of any control system. RS is the input and CS is the output. So the transfer function is the CS by RS. CS is the Laplace transform of output to the Laplace transform of input. This is the transfer function of open loop system. And here this is the block diagram of closed loop control system. GS is the transfer function of the main path and HS is the transfer function of the feedback path. Here we can see that the transfer function of closed loop system is the ratio of GS upon 1 plus GS plus minus GS HS. Plus minus depend upon the feedback, whether it is negative feedback or positive feedback. RS is the reference input, CS is the controlled output, and ES is the actuating error signal. Here it is block diagram representation of control systems. We can represent a control system with the help of a block diagram. This is the simple block diagram of any control system. Here GS is the transfer function of the main path and HS is the transfer function of the feedback. RS is the reference and CS is the control output. Here the output through this feedback is going to this summing point where RS is coming and the feedback is coming. This point is called the summing point, and where the signal is taken and it is transferred to any point, this is called the takeoff point. This is the symbol of any summing point. Here two signals are coming, A and B. The summing point will sum the two signals and we are getting at output y is equal to A plus B. Now this is the takeoff point where from where we can take this signal and we can send the signal to the other points. This is the takeoff point. Now how we can connect the blocks of any control system. Here there are two control systems. One is having transfer function G1s and another one is G2s. Here these two blocks are connected in the series. The output of first is directly connected to the input of the second one and we are getting the final output YS. As we can see that the output of first one is ZS into XS, ZS into X1s. This is the output of the first control system, and the output of second block will be YS is equal to G2s and Z1s. Now the final output will be the multiply of these two transfer functions. YS will be the G1s and G2s. So we can replace this system with a single transfer function having the value GS is equal to G1s into G2s. Now this is the parallel connection of the blocks. Here two transfer functions are connected in parallel. The input is common axis, this is distributing, and it is one part is going through G1s and second is G2s, and output is sum of the two outputs. Here we can say that ys is equal to the sum of two outputs, one y1s plus y2s. Y1s is the g1s into xs and y2s is the xs into g2s, and finally ys will be g1s xs plus g2s xs. And we can say that this system can be replaced by the single one having the transfer function direct sum of the two transfer functions g1s plus g2s. Now third is the feedback connection. Here we can see that the output is fed back to the input and the error signal is generating. The error is the difference between this input signal and this feedback signal. Es is the xs minus hs into ys. Now ys is what? Ys is the es into gs. Now putting the value of es into this equation, we can get the final transfer function of this feedback connection. Ys upon xs is equal to gs upon 1 plus gs into hs. This is the final transfer function of the system having feedback. Now we come to the test signals. Standard test signals are the signals which are used to estimate the performance and characteristics of the system by analyzing the responses of these signals. The fundamental standard test signals are impulse signal, step signal, ramp signal, and last one is parabolic signal. Now this is the first test signal, which is very important, unit impulse signal. A unit impulse signal is represented by delta t, and delta t, its value is 0 if t not equal to 0, as it is shown in the figure, and the integration from 0 to 0 plus delta t is always 1. The following figure shows the unit impulse signal. At 0 its value is 1, and other than 0 it is not defined. This is the fundamental signal, standard test signal. Now another test signal is the unit step signal. It is also very important. A unit step signal is represented by ut, and it is defined as ut is 1 if t greater than equal to 0, and its value is 0 if t less 0, at it is shown in the figure. From 0 up to infinity its value is always 1, and it is shown in the figure, and before 0 its value is always 0. This is the second very important standard signal. Now next signal is the unit ramp signal. A unit ramp signal is defined by the RT, and it is defined at RT is equal to t if t greater than equal to 0, and it is 0 if t less 0. हमेशा जो रैम्प सिग्नल होगा उसका वैल्यू अगर t का वैल्यू 0 से छोटा है तो 0 रहेगा, और t से बड़ा है तो it will follow t. We can write the unit ramp signal in terms of unit signal. RT is equal to t ut. Why we can write this? Because we know that the value of ut is 1 if time is greater than 0. So for t greater than equal to 0 ut will be 1 and RT will be again t, and for t less than 0 ut is again 0, so RT will be 0. So it is satisfied. Now the last standard test signal is the unit parabolic signal. A unit parabolic signal is defined by pt, and it is defined as t square by 2 for t greater than equal to 0. For t less 0 its value is 0. We can write unit parabolic signal pt in terms of unit step signal ut, at pt is equal to t square by 2 ut, and the graph of the parabolic signal is shown in the figure. We can say that if t is less 0, if t is less 0, and we know that ut is 0 in this range, and putting the ut 0 we get pt is equal to 0 for t less 0, and if the value of t is greater than 0, for t greater than 0 the ut is 1, and p2 will be t square by 2. So for this lecture it's all. Any questions? Thank you.
सर स्टॉप भी तो करनी है,
तो अपने आप कर लेगा ना सर।
नहीं नहीं सर स्टॉप करनी होगी।
बोला उन्होंने ऐसा?
हाँ जहाँ से स्टार्ट होना था वहीं से स्टॉप है। क्या प्रेस करना था? नहीं, मेरे हिसाब से आई गेस इसी में कुछ था। बटन्स का ही था।